Hey you guys, I'm going to do 8-3 triangle similarity theorems. There's only 2 of them. We're going to do the side similarity theorem, and we're going to do side similarity theorem. We have already talked about the angle similarity, okay? So the first one's pretty easy. If all 3 of these sides are proportional to all 3 of the second triangle, then the 2 triangles have to be similar, okay? So if the 3 sides of the 2 triangles are proportional, so we'll say if all 3 sides of 2 triangles, okay, if their lengths are proportional, sorry.
Pardon the interruption. I have our bus information for this afternoon. Bus number 8 is not in service. Students that ride bus 8, please remain at the high school, and bus 38 will return at 4 p.m. Bus 102 is also not in service. Students, please get on bus 58 at dismissal and travel to Critchfield. At Critchfield, please transfer to bus 39 to go home. Bus 18 is also not in service. Students, please get on 47 at dismissal to travel to Kingsbury. At Kingsbury, please transfer to bus 9 to go home. Thank you.
Okay, so we're saying if the lengths of all these 3 sides are proportional to the lengths of these 3 sides, then the 2 triangles are similar. I'm going to put it in words we've been doing. If the ratios of the corresponding sides are equal, then the triangles are similar. Okay? When I'm saying this, I'm saying proportional. So I'm going to always do this. Well, I'm going to just give you sides, okay? Let's go. This is 2, this is 6, this is 5. Okay? Let's say this is 3, this is 9, and this is 7.5. Okay, what we're going to check, okay? Well, first I'm going to put small, medium, large on each of these, so it keeps it in my head better. I don't have another color. So I'm going to go small, medium, and long, small, medium, and long. When I write the ratios to check if they're proportional, I'm going to write the shortest side to the shortest side. I'm going left to right. Long side to long side. Medium side to medium side. Okay? Are these 3 ratios equal? That's all I'm checking. Are the ratios equal? Okay, so divide it. Showing you. Some of you guys can look at this and see they're all 2/3, but some can't, and so that's okay. So you're going to punch in your calculator 2 divided by 3. 2 divided by 3, and I got 0.6 repeating. 6 divided by 9, I get 0.6 repeating. 5 divided by 7.5, 0.6 repeating. So are these 2 triangles similar? Yes. And what's the reason? Angle similarity theorem. Okay? I showed that all 3 of these ratios are equal, which means the sides are proportional. Okay, this one's a little different. Okay? This one is called side angle side. Go back to what we did a long time ago. First, what is an angle? An angle is made of 2 rays that share the same endpoint. Okay? This is an angle, and I mark the measurement with a curve. And I can tell you how many degrees are open. When I talk about a triangle, and I say this is angle A, the sides of angle A, these are called included sides. They're the sides that make the angle, right? So side AB and side AC, these are called included sides of the angle, okay? So the included sides of an angle are the sides that make the angle. Just something to remember as we're talking. Okay? So now we're going to say this. Okay, if we have to have two things. Number one, we have to have one pair of angles are congruent. Okay? If one pair of angles are congruent. Okay? And number two, the included sides. So this side is an included side, and this side, included side of the angles, this side and this side. If the included sides are proportional, then the triangles are similar. And really, we're talking about the lengths of the sides. It's not really sides, it's the lengths of the sides are proportional. Then, the triangles are similar. Okay? And I left a space here, okay? This means the ratio, right? The ratios are equal. The ratios of the corresponding sides are equal. So if I'm going to call this A, this B, this C, this is D, if A is to C as B is to D. Okay? Another thing you're going to see me do is I'm going to go short side, long side, short side, long side. Okay? If the ratio of the short side to the short side equals the ratio of the long side to the long side, right? Then they're going to be similar triangles. So we had to say first, you have a pair of angles that are congruent. Okay, we're going to show these two ratios are equal. Then we're going to say the triangles are similar. And we'll write our similarity statement. Okay, let's do just a couple of these, okay, and see what we got. I would like to start with, you'll see why in a little bit, okay? Let's go to, I'm going to go to number 10. Okay, let's go to number 10. Okay, we're going to go short, medium, long, so I can match things up right. Short, medium, long. Some of you guys don't need to do this. Short, medium, long. It just keeps it organized. And I'm talking about 3 sides and 3 sides, right? If the directions say, are the triangles similar? If yes, write the theorem, and then write the similarity statement. So first we got to see, are they similar? And since we're talking about 3 lengths, I'm going to use my side, side, side theorem, which means I have to check, are the ratios between the sides all equal? So I'm going to go short side to short side, and then medium side, and it doesn't matter if you go in this order, and long side to long side. So 21 to 18, I'm going from left to right, so I have to keep the pattern the same. 28 to 24, 35 to 30. And then I'm going to get my calculator, and I'm going to divide each one of them. Okay? So 21 divided by 18, I got 1.16 repeating. 28 divided by 24, 1.16. Whoa, 2 of them are equal. 35 divided by 30, and I got the same thing. So this means, are they equal? Yes, indeed they are. So are these triangles similar? Yes. Triangles are similar. And we use the side, side, side similarity theorem. Now, look at how they match up. Remember, when you match them up, that's important. I'm going to write D, C, E. It doesn't matter what order I do the first one. Is similar to triangle. Now look at this. I'm going medium, small, long, medium, small, long. These 2 triangles just slide over. There's no flipping, so I could just do the same thing. D matches up with K. C matches with J. E matches with L. Okay, that's number 10. And then we'll do number 7, and that's all I'm doing with you. You guys got to do the rest of your own, okay? Number 7, I've got an angle and an angle. These are both right angles, which means they're 90 degrees, okay? And I have 2 pairs of sides. So if this is going to be similar, right, I only have 3 ways that I could prove it. Angle, angle similarity, side, angle, side similarity, or side, side, side. This one would be by side, angle, side. So I'm going to check. This is my short, this is my long. This is my short, this is my long side. I'm going to put the short with the short, 24 to 18, long with the long. Let's see if they're equal. 24 divided by 18, 1.3 repeating. 28 divided by 21, 1.3 repeating. Yes, these are equal. Okay, I'm going to just show you this is general math knowledge. 24 divided by 18. I could divide both of these by 6 to reduce it, and I get 4/3. Okay, on this one, 28 divided by 21, reduced by the greatest common factor is 7, and I get 4/3. So 3 goes in a 4, 1 with 1/3. That's how this is 1.3 repeating. So yes, they are similar by side, angle, side similarity. And notice I'm going short side, 90-degree angle, long side. Short side, 90-degree angle, long side. This is just to translate. We're sliding them over. So these are easy to match up. Triangle SRT is similar to triangle. S matches up with P, R with N, T with Q. Okay? So there's our answers. This is how you do them. You gotta, some of them a little bit harder, right? That's this middle section. Up here it says, how do you make these 2 triangles similar? Well, in order for the triangles to be similar, their ratios have to be the same. So you could go 2x is to 16. And I would use the 9 and the 12 because it's way easier algebra when you're doing it that way. So 2x, these sides match up because DE matches up with AB. Those are corresponding sides. So 2x is to 16. And don't pick the 6 and x plus 2 because then you're going to just have more variables. Pick a constant, 9 to 12. And you can reduce that fraction first if you want. Think about what I said here when you do the other ones. Okay, that's it, you guys. That section's not bad. Good luck. See me during class. Ask me questions.